The 2014 Pacific typhoon season is an ongoing event in the annual cycle of tropical cyclone formation, in which tropical cyclones form in the western Pacific Ocean. The season will run throughout 2014, though most tropical cyclones typically develop between May and October. The scope of this article is limited to the Pacific Ocean to the north of the equator between 100° and 180th meridian. Within the northwestern Pacific Ocean, there are two separate agencies that assign names to tropical cyclones, which can often result in a cyclone having two names. The Japan Meteorological Agency, JMA, will name a tropical cyclone should it be judged to have 10-minute sustained wind speeds of at least 65 km/h anywhere in the basin, whilst the Philippine Atmospheric, Geophysical and Astronomical Services Administration, PAGASA, assigns names to tropical cyclones which move into or form as a tropical depression in their area of responsibility located between 135° and 115° N between 5° N and 25° N regardless of whether or not a tropical cyclone has already been given a name by the JMA. Tropical depressions that are monitored by the United States Joint Typhoon Warning Center, JTWC, are given a number with a W suffix. Seasonal forecasts. During each season, several national meteorological services and scientific agencies forecast how many tropical cyclones, tropical storms, and typhoons will form during a season and/or how many tropical cyclones will affect a particular country. These agencies include the Tropical Storm Risker, TSR, Consortium of the University College London, Philippine Atmospheric, Geophysical and Astronomical Services Administration and the Taiwan Central Weather Bureau. During October 2013, the VNCHMF predicted that 1 to 2 tropical cyclones would develop and possibly affect Vietnam between November 2013 and April 2014. Within its January-June seasonal climate outlook, PAGASA predicted that 1 to 2 tropical cyclones were likely to develop and/or enter the Philippine area of responsibility between January and March, 3 to 6 for April to June, 8 to 10 during July to September, and 5 to 7 were predicted for the October-December period. Season summary. Storms. Tropical storm Lingaling. On January 15, the JMA started to monitor a tropical depression that had developed within an area of high vertical wind shear about 730 km to the southeast of Manila in the Philippines. PAGASA then named the system Agatan early on January 17. The next day, its circulation became a bit exposed as it intensifies into a tropical storm by the JMA, naming it Lingaling. The JTWC upgraded it to a tropical depression, giving the designation No1W later that day. The storm reached its peak intensity at noon of January 18, before the JTWC issued its final advisory late on January 19. Early on January 20, Lingaling was rapidly downgraded to a tropical disturbance, before its remnants were absorbed by a cold front early on January 23. Floods and landslides killed 70 people in the Philippines. A total of nearly $13 million of damage loss from Lingaling, due to heavy rainfall for 3 days. Tropical Storm Kajiki. 1 week after the first storm of 2014 dissipated, the JMA reported that another tropical depression had formed east of Yap on January 29. Due to warm waters, the system organized and strengthened into Tropical Depression No2W by the JTWC on January 30. The next day, both the JMA and PAGASA upgraded it to a tropical storm, naming it Kajiki by the JMA and Basiang by PAGASA. The JTWC upgraded this storm to a tropical storm later that day, as it slowly intensified with convection. According to PAGASA, the storm made landfall over Siargao Island on January 31. Due to the unfavorable conditions in the South China Sea, Kajiki dissipated late on February 1. During its duration, Kajiki killed 6 people in the Philippines. Typhoon Faxai. Late on February 15, a tropical disturbance was spotted near Shug, near the equator, and was later designated as Invest 93W, which was moving slowly within an area of high vertical wind shear. Upon moving into an area of lower vertical wind shear, the storm was able to consolidate and organize. On February 27, the disturbance was upgraded to tropical depression status by the Japan Meteorological Agency, and the Joint Typhoon Warning Center issued a tropical cyclone formation alert for the system. The following day, it was upgraded by the JTWC to a tropical depression, and designated as O3W. Several hours later, the JMA upgraded the system to a tropical storm and named it PAGASA. PAGASA began to rapidly intensify into a severe tropical storm, and then a typhoon, for a short period of time on March 4. The system became extratropical on March 6, before it fully dissipated several thousands of kilometers southeast of Japan, late on March 8. Tropical Depression O4W, on March 12, a tropical disturbance formed southeast of Guam. Early on March 18, the JMA reported that it had intensified to a tropical depression, which had developed about 395 km east-northeast of Core, Pale. Over the next few days, the system became more organized and it was named Siloy by PAGASA on March 21. Late on March 22, the system was designated as O4W by the JTWC. Due to less convection and land reaction on March 24, the system was downgraded to a disturbance and dissipated later that day. The remnants continued to move westward towards the South China Sea, before dissipating completely to the southwest of Vietnam on March 27. Tropical Storm Viper, on March 30, a cluster of thunderstorms formed near the equator and Papua New Guinea. The large cluster separated into two systems, with the other strengthening into cyclone Eta. It intensified into a tropical depression on April 2 and strengthened into O5W by the JTWC the next day. The next day, convection built up and the system intensified into a tropical storm, prompting the JMA to name it Viper. Early on April 9, Viper weakened to a tropical depression. Later on April 10, the JMA declared that Viper had dissipated as the JTWC classifies that it is still a tropical depression. The JTWC issued its final warning on Viper later that day, while the storm's remnants continued to move slowly northwestward towards the eastern Philippines. Severe tropical storm Tapa, early on April 27, the JMA reported that a tropical depression had formed about 515 km south-southeast of Hagayenta ± Guam. Later that day, the JTWC upgraded it to Tropical Depression O6W as it moved north. Due to warm waters, the system rapidly intensified into a tropical storm with the JMA naming it Tapa on April 28. Later that day, convection occurred and the system was upgraded to a severe tropical storm. Early on April 29, the JTWC upgraded Tapa into a minimal typhoon, but the JMA upgraded it to a typhoon. It weakened back to a tropical storm late on April 30. On May 2, the JMA downgraded Tapa to a depression due to a very exposed circulation. Later on the same day, the remnants of Tapa were absorbed by a developing extratropical system. Tropical Storm Mitag, late on June 6, a low-pressure area formed near the island of Guangdong, China, embedded from the monsoon trough. The next day, the system slowly moved in an eastward direction. Early on June 9, the JMA reported that it intensified into a tropical depression which had developed about 115 km to the south-southeast of Hengchun, Taiwan. On June 10, PAGASA named the system Esther, as it brought flooding to the Philippines. On the night of the next day, convection increased to the system as the JMA upgraded to Tropical Storm Mitag. In the same time, the JTWC classified it as subtropical. Very early on June 12, the JMA issued its final advisory on Mitag, as the system was absorbed by a developing extratropical cyclone located north of Japan. Due to the southwest monsoon enhanced by Tropical Storm Mitag bringing rains to the Philippines, PAGASA reported that the official rainy season started on June 10. Tropical Storm Hagibis. Similar to the formation of Mitag, a small circulation started to develop in the South China Sea, late on June 8. Early on June 11, the system was upgraded to a tropical disturbance. On June 13, the JMA classified the storm as a tropical depression, as it started to move slowly towards the northeast. Early on June 14, the JTWC issued a TCFA alert on the tropical depression. Later that day, the JTWC upgraded the storm to Tropical Depression 07W, and at the same time, the JMA upgraded it to a tropical storm, naming it Hagibis. Early on June 15, Hagibis made landfall over southern China. During the next day, both agencies stopped issuing warnings on the system, as it rapidly weakened to a tropical depression over land. Its remnants still continued to move northward. On June 17, the remnants of Hagibis curved eastwards, as it regenerated into a tropical storm. As a result, the JMA reinitiated advisories on Hagibis. Late on June 17, Hagibis transitioned into an extratropical cyclone. On June 21, the remnants of the storm were absorbed by another developing extratropical cyclone to the north. The system moved out of the basin on June 23. About 13,000 people were affected by the storm. Economic losses from Hagibis reached a total of 577 million yuan. 2 days later, it was topped to 675 million yuan, and reached a total of $131 million as of June 20. As of June 19, the Chinese government had reported that there were 11 casualties in regions affected by Hagibis. Typhoon Neogari. A weak tropical disturbance formed near Guam on June 30. On July 1, it further intensified due to warm sea surface temperatures and convection, and it was upgraded to a tropical depression late on July 2. The next day, it was classified as Tropical Depression 08W by JTWC. Early on July 4, it was upgraded to a tropical storm by both agencies, with the latter naming it as Neogari. Later that day, Neogari rapidly intensified into a minimal typhoon. Early on July 5, it once again rapidly intensified and was upgraded to Category 4 status by the JTWC as the eye developed clearly. In the same time, the storm entered the PAR, with PAGASA giving it the name Floretta. Late the next day, Neogari entered an area of very warm sea temperatures as it intensified into a super typhoon by the JTWC and reached peak intensity early on July 7, with the JTWC refusing to upgrade it to Category 5 status. Early on July 8, Neogari weakened to a Category 3 typhoon and PAGASA stated that the storm had exited their area later that day. Late the next day, Neogari further weakened to a severe tropical storm by the JMA. Due to the strong jet stream, Neogari moved in an eastward direction instead of moving towards Korea. On July 10, JMA downgraded the system to a tropical storm as the JTWC made their final warning and stopped issuing advisories. At the same time, Neogari's circulation became totally exposed as it was affecting southern Japan. JMA made their final warning early on July 11, as Neogari started to become extratropical. The extratropical remnants of Neogari collided with another weak, developing system north of it on July 14. Typhoon Ramasan. During July 10, the JMA and JTWC reported that a tropical depression had developed to the southeast of the Mariana Islands, with the latter assigning it the designation 09W. On the night of the same day, JTWC downgraded 09W to a tropical depression as it passed through Guam, entering an area of favorable conditions and low vertical wind shear on July 12. Later that day, the JMA had upgraded it to Tropical Storm Ramasan. Tracking westward at over 15 knots, the system's convective banding became more persistent. Ramasan held that intensity as it entered the PAR, with PAGASA assigning the name Glenda on July 13. The system finally gradually developed further to a severe tropical storm as it entered an area of favorable environmental conditions, warm waters and low vertical wind shear. Both the JMA and the JTWC upgraded Ramasan to a typhoon, as an eye developed. In the morning hours of July 15, Ramasan further intensified into a Category 3 typhoon with a minimum pressure of 945 millibars. With JTWC's best track data, they upgraded it to Category 4 status, as it made landfall over Al Bay. Due to land interaction, Ramasan rapidly weakened to a minimal typhoon and its eye collapsed late on July 16. Later that day, the storm entered the South China Sea and re-intensified to a Category 3 typhoon. On July 18, Ramasan entered another area of very warm sea surface temperatures, as it strengthened to Category 4 super typhoon status again by the JTWC, but this time it reached its peak intensity. Later that day, the center of Ramasan made landfall over Hainan. The next day, the storm started to weaken and it weakened to Category 2 strength. Later that day, both agencies downgraded Ramasan to a tropical storm as it moved to the province of Guangxi and made its third landfall. JTWC made its final warning on the system on the night of the same day. Early on July 20, the JMA reported that Ramasan had weakened to a tropical depression before it was last noted later that day over the Chinese province of Yunnan. As of July 17, it is reported from NDRRMC that the death toll has reached 40 and the total amount of damages were amounted to 1 billion. In China, 18 persons were killed due to the storm. Typhoon Matmo. Late on July 13, the intertropical convergence zone spawned another tropical disturbance. But due to Typhoon Ramasan being nearby, the disturbance started to weaken. The next day, it gathered warm waters and favorable conditions. Very early on July 16, the JMA upgraded the system to a weak tropical depression, as it started to show signs of intensification. At the same time, the JTWC issued a TCFA alert on the system. The next day, the JTWC upgraded the system to Tropical Storm 10W, while the JMA named the system Matmo, after it strengthened to a tropical storm. Early on July 18, Matmo entered the PAR, with PAGASA giving it the name Henry. On July 19, the JMA upgraded the system to a severe tropical storm. During the next day, Matmo began to slowly intensify to a typhoon. The JTWC, on the other hand, still classified the system as a tropical storm. Later that day, the JTWC upgraded it to a Category 1 typhoon. At the same time, Matmo curved towards the northwest. Late on July 22, the JMA downgraded Matmo to a severe tropical storm. Early the next day, the JTWC instead upgraded Matmo to a Category 2, as the storm re-intensified. With that, a small unclear eye developed in Matmo's center. One person was reported dead and there was some damage reported. At least 48 people died in a plane crash in the Taiwan Strait. The crash may have been caused by the typhoon. As of July 24, according to the Ilan County government, the agricultural damage in the county was estimated at about 44 million new Taiwan dollars. Severe tropical storm Nakri. On July 19, a tropical depression formed to the southeast of Guam. It slowly moved in a northwest direction over the next few days. Early on July 22, the JTWC issued a TCFA alert, but later that day, the system lost its organization, and was downgraded to a low-pressure area. Early on July 24, the low-pressure area reformed east of Pile. JMA upgraded the system to a tropical depression early on July 26, as it started to move in a northward direction. The depression continued to intensify, even though it didn't reach tropical storm strength. Due to weakening convection east of the storm's center, it started to weaken on July 28. Later that day, more convection increased in the western side of the storm, and it began to re-intensify. On July 29, the JMA upgraded the system to Tropical Storm Nakri. The JTWC, on the other hand, still classified it as a disturbance or monsoonal depression, even while deep convection was occurring in Nakri. Due to the deep pressure of Nakri, the JMA upgraded it to a severe tropical storm on July 31. Early the next day, the JTWC issued its final advisory, without upgrading the system to a tropical depression. On August 2, the JTWC reissued some advisories of Nakri, and was reported having winds at 35 kts as a tropical storm, and was given the designation 12W. Typhoon Halong. On July 26, the JMA began to monitor a low-pressure area near Shuk. After the system stalled for a few days, it was upgraded to a tropical depression on July 28. Early on July 29, the depression showed signs of intensification, and with that, the JTWC upgraded it to Tropical Storm 11W. Later that day, the JMA upgraded 11W to Tropical Storm Halong. At the same time, Halong started developing a small, unclear eye. Around this time, gale and typhoon force winds were reported over Guam. For over 24 hours, Halong's intensification stalled due to unfavorable upper-level winds and strong vertical wind shear. Very late on July 30, JMA upgraded Halong to a severe tropical storm, as the storm resumed its intensification. During the next day, both agencies upgraded Halong to a minimal typhoon. At the same time, Halong started undergoing rapid deepening. On August 2, Halong's developed a clearer eye, and then it intensified to a Category 2 typhoon in less than 24 hours. At the same day, due to excellent equatorial outflow and favorable conditions, it rapidly intensified into a Category 5 super typhoon. At the same time, PAGASA had reported that Halong had entered their area of responsibility, and assigned it the name Jose. On August 4, Halong underwent an eye wall replacement cycle, and consequently, it weakened to a Category 4 typhoon. Typhoon Genevieve. On August 7, Hurricane Genevieve entered the West Pacific Basin at Category 4 super typhoon status. Later that day, the Joint Typhoon Warning Center upgraded the system to a Category 5 super typhoon. Genevieve entered an area of favorable conditions and low vertical wind shear, as it continued to intensify. Later on August 7, Genevieve reached its peak intensity, with winds of 110 knots, and with this, it became the strongest storm within the Northwest Pacific in 2014. On August 9, Genevieve started to move in a northward direction, towards low to moderate vertical wind shear. Later that day, the JTWC downgraded the system to a Category 3 typhoon. Later that day, Genevieve rapidly weakened to a strong Category 2 typhoon, as it began to encounter increasing wind shear and drier inflow, to the south of the system. At the same time, the eye of the typhoon began to shrink. On August 10, Genevieve weakened to a minimal typhoon, as it began to develop a secondary eye, but the secondary eye soon disappeared, due to the storm moving over cooler waters. Other storms. On January 10, the JMA started to monitor a tropical depression that had developed about 370 km to the southwest of Pile. Over the next 2 days the system became disorganized as it moved towards the north-northwest, before it was last noted during January 12, as it affected Mindanao. During March 11, the JMA monitored a tropical depression that had developed about 195 km to the east of Mati City, Philippines. Over the next day the system moved westwards, before it was last noted within the Celebes Sea on March 12. Late on April 13, the remnants of Viper regenerated into a tropical depression to the east of the Philippines, while slowly continuing to approach the island nation. On April 15, the depression became disorganized and the system's convection was displaced from its center of circulation, prompting the JTWC to issue its final advisory on the system. During the next several hours, the remnants of the depression turned towards the southwest, until it dissipated late on April 15, just off the northeastern coast of the island of Mindanao. On April 17, PAGASA downgraded it to a low-pressure area and issued their final advisory. On April 19, the JMA reported that a tropical depression had developed about 490 km southwest of Haga plus or minus Guam. Due to less convection and cool waters on April 21, the depression weakened to a disturbance while still moving west. The remnants of the depression affected the northern Philippines and dissipated on April 23, due to land interaction. On August 15, an area of low pressure developed in the Philippine Sea. Later on the same day, it organized into a tropical disturbance. The system continued to move in a westward direction, as it affected the Philippines, causing heavy rainfall and spawning a waterspout near Cavite. The system was upgraded to a tropical depression early on August 19, as it continued to intensify. The storm soon affected China as well. However, the JMA issued its final advisory later that day, as it was absorbed by a stationary front. Names, international names. Tropical cyclones are named from a set of 5 naming lists set by the JMA's Regional Specialized Meteorological Center in Tokyo, Japan, once they reach tropical storm strength. Names are contributed by members of the ESCAPWMO Typhoon Committee. Each of the 14 nations and territories submitted 10 names, which are used in alphabetical order, by the official English name of the country. The next 30 names on the naming list are listed here along with their international numeric designation, if they are used. Genevieve entered the Northwest Pacific from the central North Pacific, becoming a typhoon and retaining its name assigned by the National Hurricane Center. It was given the international designation 1413 by JMA. Philippines, PAGASA uses its own naming scheme for tropical cyclones in their area of responsibility. PAGASA assigns names to tropical depressions that form within their area of responsibility and any tropical cyclone that might move into their area of responsibility. Should the list of names for a given year be exhausted, names will be taken from an auxiliary list, the first 10 of which are published each year before the season starts. Names not retired from this list will be used again in the 2018 season. This is the same list used in the 2010 season, with the exception of Jose and Cana, which replaced Juan and Catherine. The name Jose was used for the first time this year. Auxiliary list. Season effects. This table will list all the storms that developed in the northwestern Pacific Ocean west of the international date line and north of the equator during 2014. It will include their intensity, duration, name, areas affected, deaths, and damage totals. Classification and intensity values will be based on estimations conducted by the JMA. All damage figures will be in 2014 USD. Damages and deaths from a storm will include when the storm was a precursor wave or an extratropical low. See also: List of Pacific typhoon seasons, 2014 Pacific hurricane season, 2014 Atlantic hurricane season, 2014 North Indian Ocean cyclone season, Southwest Indian Ocean cyclone seasons, 2013 Euro 14, 2014 Euro 15, Australian region cyclone seasons, 2013 Euro 14, 2014 Euro 15, South Pacific cyclone seasons, 2013 Euro 14, 2014 Euro 15, footnotes. References. External links: Japan Meteorological Agency, China Meteorological Agency, Digital Typhoon, Hong Kong Observatory, Joint Typhoon Warning Center, Korea Meteorological Administration, National Weather Service Guam, Malaysian Meteorological Department, Philippine Atmospheric, Geophysical and Astronomical Services Administration, Taiwan Central Weather Bureau, TCWC Jakarta, Thai Meteorological Department, Typhoon 2000, Vietnam's National Hydrometeorological Service.